third was another team, and the second was OHM,
Yeah.
first was us.
Alright, now, quick picture.
Alright, you got it?
Good, go to you, girl.
Like, well, like, they always give us a second, like,
I record?
like, because we can't
Alright.
get everything.
Yeah.
So did they
Like, going to the-
Alright.
Coming back next week.
The little red dots on?
No. What?
You're not gonna tell me this is
And
not
also
playing.
a display.
Didn't
All right.
you turn it on?
Oh yeah, that was good.
They didn't even check, right?
But then he turned it on right.
Yeah.
So we're good.
I appreciate that.
Alright, so here we go. Sorry for the interruption. Forgive me those of you watching.
You're so bad.
One of them.
So, back to this.
Done for.
We were saying that a logarithm, the answer to a log problem was a what? An exponent, right? Okay, so all the rules that you learn for exponents, all the laws of exponents apply to logarithms as well. For example, when you multiply exponents with the same base, what do you do with the exponent? You add the exponents, right? So on and so forth. Those properties also exist with logarithms. So we're going to talk about them. But before we do that, let's look at the graph of ln of x and see if we can come up with it, okay? Yeah?
Yes.
Alright, so let's plug in some numbers and see what we end up with, okay? Now be careful here because you have to think of it differently because here we're plugging in y's and our answers are going to be x's, okay? So that's the difference here. So let's pick a y value. Let's pick 0 as a y value. So what happens when I put 0 in there? What's e to the 0 power?
1.
1. So that means when I put 0 for the y, my x has to be 1. So I have to go 0 and then I have to have the 1 value right there. You understand? What happens if I put in 1? What's e to the first power?
E.
E. Does anybody know the approximate value of e? 2.718.
Oh yeah, that.
So approximately right there, right? When y was 1, what was the x value? 2.718. Okay? What if I picked a number smaller than 0, like -1? If I put -1 there, what would e to the -1 be? So if I send it down, I get 1 over e, okay? Can this answer ever be 0? Can I put a power in for y that will make my answer 0?
No.
No? Why not? What if I put a really big negative number, like e to the -1,000? That won't be 0? No? What would that be, e to the -1,000?
1.
1 over e to the 1,000 power, right? Because the negative exponent sends it down. It's still a really big number in the denominator, right? But is it 0? No, it's something that's really close to 0 but not equal to 0, right? So I can never have this e to some power to where it will make it 0, but it will get really close to 0. So what happens is this graph, this curve, comes down like this and it gets really close to the x being 0, but never. And then it grows like this. So what do we have here at this 0?
Vertical.
A vertical asymptote. Okay? So the function here, there's no y value that when I plug into it will ever make it 0. That's why I have a vertical asymptote. Cool? So what are some characteristics that you notice about it? What's happening to the curve? What is its behavior? Okay?
It's increasing.
It's increasing. Those are the words that I need you to tell me, right? So it's increasing when?
On all values greater than 0.
So always, right? Okay, in its domain, it's always what?
Increasing.
Increasing. Let's write that down. So it's always increasing. There's a special name for functions that are always increasing or always decreasing. Okay, functions that are always doing the same thing. And that word that they use is called monotonic. Okay, what does mono mean?
Singular.
Singular, right? Or one, right? So they're doing one thing. What is the one thing that they are doing? They are either increasing all the time or they are
Decreasing.
decreasing all the time, okay? So same word means two things, okay? Cool? So if the function's always increasing, what can you tell me about the derivative? What would the y prime be?
Positive.
Positive, so that means it's greater than what?
0.
Greater than 0. Right? The derivative is positive, the function is increasing. Cool. What can you tell me about the concavity of that curve? There's two choices, concave up or concave down. Concave up like a cup
No.
or concave down like a frown?
Down.
Down, so this is concave down. Okay, so if I did tangent line approximations like we did a couple of weeks back, right, we would find equations of tangent lines, and then we would use them to approximate values on the curve, right? What would my approximations be, above or below?
Above.
Over or under approximations?
Over.
Over, right, because my tangent lines would be where?
On top.
It would always be above the curve because the curve is concave what? Down. Remember that?
Mm-hmm.
That's why my approximations would be over estimates and not under, right? Okay, what would be my domain for this curve in interval notation? So domain is the x values that you can go to and touch your graph, right? So what are the x values that I could go to and touch my graph at? Can't touch it here. Can't touch it at 0. But right after 0 I can start touching it, right?
Mm-hmm.
So it would be from where to where?
0 to infinity.
From 0 to infinity. And we need parentheses because 0 is what?
Not included.
Not included, right? If it were included, we would put what? Brackets. Okay, what would be my range? Negative infinity to positive infinity. So range, now we're talking about y values that I can touch my graph at, and it looks like we can touch it at all the y values. Okay, so another way of saying that would be all what?
Real numbers.
All real numbers. Very good. Not the imaginary ones. Okay? Cool? Alright, how about these limits? Let's see if we can do them. What's the limit as x approaches 0 from the right?
Negative.
Negative what? Negative infinity. So as I come on my curve and I get closer and closer to 0, where is my graph going? Negative infinity. What would the limit be as I approach 0 from the left? Why?
Because there's nothing there.
There's nothing there. You can't even get on the curve to approach it from the left, right? So that means the limit at 0, what?
Does not exist.
Does not exist, okay? So what must be true for a limit to exist?
The limit from the left must equal the limit.
The limit from the left must equal the limit from the
Right.
right. Very good. We can't forget about that stuff, okay? All the way till May when we take the test, we gotta remember all that. What's the limit as we approach infinity? What does that mean? What is that telling us to do? Go to the right. So as I go forever to the right, where's the curve going?
Infinity.
Positive infinity. Easy? Just random review of limits, throwing stuff in there. Okay. Now let's get to the fun stuff, the properties of logs. Alright, so if I say ln of 1, if I'm asking for that question, I'm asking you to find the power of what? What is ln the same thing as? Log
Log of e.
base e, right? So log base e is the same thing as ln. So I'm telling you to find the power of e, the power of e that equals 1. So what's the power of e that equals 1?
0.
0, okay? So this is true because if I write this in exponential form, it would be e to some power x is equal to what? 1. Okay, there's an imaginary e here that they don't write. So e to this power equals 1. So that's only going to equal 1 when that power is what? 0. How about ln of e?
1.
What's that going to be?
1.
1. Okay, so why? E to what power equals e, right? That's what we're trying to find. E to what power equals e? Well, it has to be what? 1. Some of you learned in pre-cal and algebra 2 that ln and e work what of each other? Inverses, right? And what do inverses do to each other?
Cancel each
They cancel each other out, right? So here ln and e, when you're finding ln of e, they cancel each other out. And the exponent would be the answer. So what's the exponent of e here? 1, so that's why my answer is 1. Okay? How about this one? What is this going to be? 2, right? ln and e would cancel out, so my answer would just simply be 2, right? But really what's happening is you're doing e to what power is equal to e squared. The only way these two can be equal is if the exponents are equal. Understand? Cool? Is this coming back? Why did I put so there? That's funny. Cool?
Yeah.
So what we did here was we rewrote it in exponential form to try to understand. Over here what we're going to do is practice the expansion properties. So remember, these are related to the laws of exponents actually, okay? Yeah? So what's happening between the arguments here? They're multiplied, right? So we're going to remember, when we multiply, you add the exponents, right? So ln of all this is some exponents, right? So this would be like saying ln of a plus ln of b. Got it? What's happening here? We're dividing, right? So when you divide, subtract the exponents. Remember we did the lawnmower? When you divide! Remember that?
I don't only know
Okay, the
that
lawnmower?
weird costume.
Subtract the exponents, yeah?
What costume was he in?
So this would be ln of a minus ln of b. So when you're expanding, you're rewriting the problem in more than one logarithm, okay? You're welcome.
What's your name? I'll send it to you.
Okay, so let's look at this last part. So this has something to a power, right? So that one's going to go with the power to a power. So power to a power, good. Power to a power, you multiply the powers. Okay, so what we would do here is the exponent of the argument goes to the front, and we have n times ln of a.
I forgot all this.
You forgot all this?
I never forget.
How can you forget this? We had so much fun speed dating.
I wasn't here for that. I was.
I didn't
They didn't have you.
I
Yeah.
feel like it was
It happens.
No, but they
Your magnet,
broke down.
magnet kids can only take with a magnet teacher.
But they're magnet. You're magnet? Yeah. Oh.
Like,
What? Why didn't you have Torres? You were
I know his class is
space.
probably.
Oh, what'd she say?
I don't know.
Wow!
Get her out. Get her out.
I remember she wanted to switch her schedule.
So did you.
No,
Oh!
I was like, hueva.
And now are the kids that abandoned me.
You're a key part of this. You're a cop for bringing this class.
I know. That's why I'm always here for you.
So basically, he's dying.
It's
I
okay.
actually requested Mr. Simon.
I know, I went to the council and requested you because I had to go with this.
Yeah, I have his
Thank
goals
you.
too.
I knew it was gonna do terrible.
Some of them didn't do that. They're just like, no, I had Gomez, so I stayed there. I'm like, oh,
Wow,
okay.
Andrea.
I see how it is.
I'm gonna tell you story cheated.
I'll remind you after the AP test.
Nice.
Alright, so other notations to be aware of, sometimes they write the log differently, so they'll say like ln squared of x. So when you see that, I don't want you to freak out. What do you think that notation means?
ln of x squared.
Very good. So ln of x, the whole thing, what?
Squared.
Squared. Okay? It's kind of like the sign notation,
I
right?
didn't hear a cough.
They're judging.
So It's just like this.
What's that?
When they do sine squared of x, you write sine of x, the whole thing squared, right? So don't freak out if you see a problem written like this. Just know that it's the whole thing squared. Okay, now can I just send this guy to the front like I did here? Or is it two
No.
different things?
It's two different things.
Two different things, right? Here, the only thing being raised to the power is the argument, right? Whatever I'm getting the ln of. Here, it's the whole ln thing being squared. So be careful, okay? Don't make that mistake. Okay, that is a common mistake that kids make. Something squared is something times itself, right? So this would actually be ln of x times ln of x, which is something totally different. Cool? Alright, so let's write those things down. We want to be careful with gotchas.
With gotchas?
With gotchas.
Is that
Gotchas.
And they're like, gotcha! You know?
Yeah, I get it.
Our gotchas.
So we want to be careful with gotchas. This is something that I learned from Miss Price. I can't take credit for this.
Wait, Miss Price from Monroe?
No, Miss Price from
What?
another state.
That's what I thought it was. Like, what?
She's from another state.
Ew.
So if I have ln of a plus b, Marilyn, usually